just in your system, can you find that plate number 3? 3 pages are there.
No, sir.
Nobody. I thought I
No,
had.
sir.
No, sir.
No, sir.
No,
So,
sir.
okay, just wait for a few seconds. Now, do you find any page here?
Yes, sir.
Yes.
It clear, visible?
Yes, sir. Clear and visible.
So,
Zoom in.
up to problem number 6, it is visible.
Sir, can you please zoom in a bit?
Now,
Okay, sir. Okay, sir.
করবেন তাহলে কি স্ক্রিনে একদম সাইজে চলে আসবে।
so take a screenshot of this where you will get up to problem number 3. Of course, it will not be required today, but most likely problem 1 and 2 we can discuss within the stipulated time. Anyway, you will get the mail for 3 pages, 2 pages with this text description and 1 page with the diagrams.
Taken, sir.
Taken. Now I unshare it. Okay. Next, now this is the complete page. Is it clearly visible on your screen?
Yes, sir.
Yes, sir.
No,
Yes.
sir.
Yes, sir.
Yes,
Not
sir.
clearly visible.
So the people, those who are with the response
Numbers are
yes.
not clear.
Now,
Yes, sir. Now visible.
Yes, sir. Now it's visible.
so take a half page screenshot. For today, it will be more than sufficient, but I will give you those pages to your mailbox.
So screenshot taken.
Sir,
Okay.
scroll down.
Now, next thing, just to hold a minute. Okay, do you find any blank screen, blank page there?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Just to
Yes,
recapitulate,
sir.
just try to remember, this was the shadow of a small sphere which is placed vertically below, directly below this light source, and on the floor we get a circular shadow here. Similarly, you have seen this kind of machine also, that LCD projector or whatever name you can call it. It is creating some shadow. Either a thin film is there in front of it, or whatever may be the mechanism, it produces that shadow here. Now, with reference to these ideas, we considered formation of this shadow on a vertical plane in some different manner. That is, the light source is so big that all the light rays are parallel to each other, so that when the object is placed directly in front of this vertical screen, it produces the shadow which gives the front face available there. If it is the viewer and your eyesight looking in that way of all these lines of sight are parallel to each other, you get this type of formation, or some sun rays which are assumed to be parallel to each other, forming this shadow. This is on vertical plane. Similarly, when we see from top that shadow formed on the horizontal plane, it is projected on the horizontal plane named as HP. It is another thing. Now these two are the primary idea for projection of any object on perpendicular surfaces with lines of sight parallel to each other. And for any such object, for its description, we take the help of this method, which is called the orthographic projection. Now, this you know that two planes which we are considering, that two infinite planes, one is horizontal, other is vertical, they intersect along this line XY, some finite portion of these two infinite planes, and it subdivides the space in four dihedral angles which are named, as you know from your higher secondary trigonometry courses, that first quadrant, second quadrant, third and fourth quadrant. Now, this is the 3D representation or pictorial representation. And if you see along this line XY, you will get this type of impression. Of course, before that, this was the description. The quadrant 1 in front of vertical plane, above horizontal plane. Quadrant 2 behind vertical plane and above horizontal plane. Quadrant 3 below horizontal plane and behind vertical plane, and quadrant 4 it is below horizontal plane and in front of vertical plane. Now if we form these two planes, the first quadrant, by this portion segregated out of this system, there we include one more plane which is perpendicular to both of these reference planes, HP and VP. It is normally called क्या PP?
Profile plane.
Profile plane.
Pictorial
plane. Plane.
Now, for some cases, we need to project that object on this pictorial plane. And as we are looking with reference to this observer from some side, it is from left side. So it is called that left hand side view. Okay. Next thing. We considered one particle, capital A, in this first quadrant. You project it, that means you draw lines passing through this point, capital A, perpendicular to this vertical plane, and this is the foot of the perpendicular, as if here is one light source and that torch is giving us this shadow. Now name of this point is having its specific rigid grammatical guideline, that is lowercase a with a prime. Sometimes we call it as a dash, small a dash. This is the view from top, small a. This is view from left hand side, small a with double dash or double prime. Now these three locations are very important because finally we will deal with these three views: top view, front view, and this side view. And here we designate these views, that is view from above or plane or top view. This is view from front or front view or elevation, A dash, and this is view from left or left hand side view. So in different way you can name them, but location is first quadrant. Here is a point, capital A. Done. Now this 3D like model presentation will not help us. For a particular point, you need three cardboards. You have to glue them together mutually perpendicular to each to the other. So that is a difficult thing and which is not practical also. So what we need to do, we present these three different views projected on these three different cardboard like things in a 2D shape. That is, you open this 90-degree first angle space or first quadrant by rotating this horizontal. Just a minute. We rotate this horizontal plane about this line clockwise, and finally it comes like this. Similarly, when we open this 90-degree to 180-degree shape or a plane, a flat surface, then VP and PP, those are presented by a single flat plane. So ultimately what we get, this is VP, HP, and this is pictorial plane. And the points capital A projected on these three planes are indicated by so this location is front view, this is the top view or view from above, and this is the left hand side view, A double dash. Now here also this 3D like thing is also not helpful for us. So what we do, we present it in this form as if three separate rectangular plates are connected to each other after opening that first quadrant space. So beta kabhi kabhi kuch awaaz karte ja, so that I understand, because I am working with this screen. I am not opening this MS Team screen, whether I have been muted or not. Okay, so
Yes.
Okay, sir.
this is the presentation of those three cardboards, VP, HP, and PP. These lines are all mutually perpendicular. As you see, there are three lines. Capital A to A prime, number 1. Capital A to lowercase a, number 2. And capital A to A double dash, it is number 3. And all these lines are perpendicular to these planes of projection. And these are all individual rectangular faces like a brick. Okay, and this angle is also 90-degree. But when you open it through this 90-degree clockwise rotation, as it is shown here, so you will find this green line is also, the second green line is looking like as if this is the extension of the previous one when it travels to come to this vertical plane extended or like that. So when you see these plates in this form, this line is called projection line. okay, or projector. But truly speaking, these are the lines. This is the projection line, this is projection line, this is projection line 1, 2, and 3. But when you open this space, we get this thing. These lines are called projectors. So plane and elevation, these are connected by a single common line, which is called that projection line, and it is a straight line at an angle 90 degree. And this line is the XY line. And this XY line has another name, GL, that is ground line. Is it clear? So
Yes.
all these are basic alphabets. We must know this thing, remember all these things, so that afterward, very smoothly we can sail through this subject. Now finally, this boundary of these cardboards will not be there. Only thing, this line of intersection between VP and HP will be there. The line of intersection between the vertical plane and the pictorial plane, this will be there, and this XY line or ground line will be extended to accommodate this side view, and this line also will be extended as a single axis from this line of intersection between VP and PP. Okay. Now, what about this distance? Distance is indicated by distance from horizontal plane. This distance is the distance from vertical plane. And if you move back to that previous diagram and erase those unnecessary lines, we are making it clumsy. Okay, now it is a little bit clear.
Sir,
Yes.
sir, front view, sir, view জিনিসটা বুঝিনি, একবার বলে দেবেন?
বাবা, এবার তুমি বই পড়ে বোঝো। আমি যদি একজনের জন্য পুরো 2.5 ঘন্টা ক্লাস আবার রিপিট করি just to satisfy you that what is view, then it is very difficult for me. And this class was taken 1 week back, and during this 1 week আপনি क्या कर रहे थे बेटा?
স্যার আপনার লেকচারই শুরু দেখেছি।
শুধু লেকচার শুনলে হবে না। There is no meaning just following this lecture. You have to supplement with so many things. YouTube में जाओ, you will find so many fantastic videos demonstration. ये मानस पटनायक का नाम सुना है आपने? You just give a Google search, and that
सर मैकेनिक्स के लिए।
हाँ, उनका मैकेनिक्स और इंजीनियरिंग ग्राफिक्स जो है, बहुत बढ़िया उनका वीडियो प्रेजेंटेशन है। वो मुझसे अच्छा बताते हैं बेटा, देख लो। Only thing, Manas Patnaik will not give you an answer to your question. For that I am here. Anyway, this is the first quadrant. Am I clear? In the first quadrant, we have placed a point capital A, a particle. We are holding a torch here horizontally, and this is the shadow. Now we hold a torch vertically directly above this particle A. This is the shadow formed here. And this is the shadow formed on the pictorial plane, which is perpendicular to both this VP and HP, just holding a torch from this side. So now do you understand these three shadows? These three are called views. If you see from front, this is the front view. If you see from top, this is the top view or view from above. If you see from left, this is the left hand side view. you have to remember this thing, because it will be very difficult for you to move forward. आप आगे नहीं चल सकते until unless you know all these alphabets. Okay. Now once we have this thing, we give these distances here. This is the distance, D capital H in subscript. It means distance from the horizontal plane, or this is the height. Distance from HP. That means how much distance or how much above horizontal plane the point capital A is located. Now this distance is dV, distance from vertical plane. This is the vertical plane, VP, and this is the distance dV, distance from vertical plane. Okay. Now this distance is also dV. This distance is also dV because ultimately you have formed a brick-like thing. These three mutually perpendicular faces, perpendicular lines are drawn from capital A to small a dash, small a double dash. So you have formed a brick. All six faces are there of rectangular shape, and that's all, a simple geometry. Okay. Now once we have those distances, next when you talk about that opened up space, first quadrant here, after that 90 degree movement, then this is the distance dH in elevation, that is height of the point capital A, that is how much above HP it is. Now this is the distance, how much away from the vertical plane, dV, it is coming in plane. So as if it is VP side, so on the other side or this other projection, this is the distance corresponding to the view from the other plane. So distance of this view is the distance from the other plane, and distance of this view from the ground line or XY, it is the distance from the other plane, that is horizontal plane. These two are different distances, or whatever values of these distances mentioned. And what more? That is, when you rotate this pictorial plane, when you open it up, then this distance from vertical plane is here, distance from vertical plane, and that distance you are getting here, that distance from vertical plane, and distance from horizontal plane, as you have seen it for elevation, for the real point, how much high it is, or at how much height is located from the horizontal plane, this is this dH, and here also for that brick formed by these mutually perpendicular faces and these perpendicular lines to all these planes of reference projection, this is also that height dH. And once we have that information, next formality is we forget about these individual three cardboard which have formed this VP, HP and PP, not in its 3D model like thing. This space has been opened to give a plane surface. HP rotated through 90 degree about XY, PP rotated through 90 degree about this line of intersection between VP and PP. And here is the other way how we can think about this different quadrants. So as if we are looking in this direction along the line XY. So if you see along the line XY, here will be something familiar diagram. You have seen in your school trigonometry, two mutually perpendicular lines are considered. So this is subdividing the space in 4 parts which are called quadrants. First quadrant, second quadrant, third quadrant, fourth quadrant. And it was for plane coordinate geometry, for horizontal line as x-axis, this point of intersection as the origin O, and this line as the vertical y-axis, positive upward. But truly speaking, when you are seeing from this is not that trigonometry familiar figure. It is showing this xy line as a single point because you are looking along the line. So this is the xy line represented by a point, and this space subdivided in 4 parts. These are quadrant 1, second quadrant, third quadrant, and fourth quadrant. And formality is you have to rotate the planes in this form or in this way, that this is to be rotated through 90 degree so that it comes to overlap on this vertical plane, and similarly this also lifts up in that clockwise sense through 90 degree and moves to other side. That means above the horizontal plane, the original horizontal plane location. So we need to open this first quadrant, and after that what you find, third quadrant opens to 180 degree, second quadrant collapses to 0 degree, and fourth quadrant also collapses to 0 degree. And once we know this formality, then this is the way how we do this thing for different quadrants. Do you get this diagram? Hello? I don't know whether I have been muted or not.
Yes, sir. Yes, sir.
Yes, sir.
कभी कभी आवाज भी दिया कर बेटा. Okay. Now.
Second one I cannot understand, sir.
Which?
Sir, the second one.
Second one. This one.
Yes, sir.
You are looking along this direction, along the line XY. If you look along this direction, you will find this vertical plane. Just you think about a cardboard placed in front of you, in between two eyes, and facing one towards the right hand side, one other face towards the left hand side, and you will find simply a line. The total vertical plane is represented by this line. जब आप लोग क्लैप करते हो ना और किसी को नमस्ते करते हो, you think about, remember about that posture. So when you close your palms and hold it in the posture of namaste, then what about that interface between those two palms, right hand and left hand? This is in that posture, in that position, that you are here and in front of your eyes, this intersected cardboard planes are placed, but you are looking along this line XY. So this line XY will be represented by a point. Suppose you have taken a pencil, and that pencil, or suppose you are one, क्या बोलते हैं, archer, a bow and arrow, खेला कभी?
Yes, sir.
So
Yes,
when
sir.
when you set one target, so how that arrow looks like? Does it look like a straight line or a point?
Point, sir. Point, sir.
That is the thing. So please try to visualize that you are looking along this direction. This is the arrow, and along this arrow you are looking. So the full straight line will come as a dot. And this space is here, the first quadrant. This space behind VP and above HP, it is here. And if I make it little larger, these things are written. HP, this is vertical plane, above HP, below HP, in front of vertical plane, behind vertical plane. Okay. Now it will be useful for us to consider the projection of points at different coordinates, different quadrants. Okay. So this is the thing. Okay. So for first quadrant, just a minute. So this is the first quadrant. Point capital A is there. From A, you drop a perpendicular to horizontal plane. This will be that shadow or projection on the horizontal plane. It will be the view from top or plane. We are not describing with its full name. Just this notation, lowercase a and lowercase a with a prime. These are acting as your ABCD etc. of your English alphabet. Okay, so here also for this subject engineering graphics, these alphabets are very much important. So once capital A is there, small a and small a dash, definitely they represent the view from top and view from front. Okay. Now next thing, perpendicular projection on the vertical plane. This is the elevation or view from front or front view. Next thing, that formality, open the space so that first quadrant is opened and this 90-degree rotation of this horizontal plane with reference to XY line, this plane comes to join or overlap on this vertical plane. So ultimately you are getting a single vertical plane on which A and A prime are both presented. So this point, the lowercase a, it comes here. And finally, the formality is this. This line is the XY line. This is the elevation or view from front or front view. This is the plane or view from top or top view. Am I clear? This formality is very much important, and if you do not remember, you will be really in some hopeless situation. These are not having any, rather in your sense, we don't find any logic. Why you call it elevation, front view, or view from front, or put lowercase a with a prime. As you do not find any meaning, that name of this drawing is pronounced as A. Name of this map is pronounced as B, or another name, another shape is like this. Is there any logic? Is there any meaning? Thousands years back, these people, they started communicating. Initially to communicate through some gesture, then some diagrams or something like that. Then finally people started speaking, and there was some formality, how to speak in some standard manner so that everybody can understand the meaning of that. So these are such information. So once we have these basic alphabets of this subject, then the subject engineering graphics becomes meaningful, which is the medium of communication between two engineers. Okay. So we draw a line, thick line XY, which is called the ground line also. This is the first step. So step 1 is this. So this is the step 1. Next step, you draw a very thin line. A very thin vertical line. And in the problem, if it is mentioned, the point capital A is 30 millimeter above horizontal plane. So that 30 millimeter to be measured here and mark a point. Put a dimension 30 millimeter. Identify this location with a very small circle. Name of this point is given. A prime, which indicates the elevation. Then if the distance from the vertical plane is given as maybe it is 70 millimeter. It may be described that point capital A is 70 millimeter in front of VP, or that distance from vertical plane, it is 70 millimeter. So you measure a distance of 70 millimeter on this projector. Put this dimension. Now all these formalities, whatever you have done in your first plate, you need to remember the extension line, the dimension line, the dimension arrowheads, and the dimension figure 70. Now somewhere at the right and bottom corner, you normally write all dimensions in millimeter. So this is the way how we mark these 2 points on a vertical, rather this line perpendicular to this ground line or XY line. And it is very thin line. We mark these points, and this becomes the view from top, or top view or plan, lowercase a. And this is the small a dash, which gives the elevation. That is for first quadrant, when the object is placed in front of vertical plane and above horizontal plane. Now, before that, this thing is very important, that we are seeing from this direction. We are not considering that 3D pictorial like or model like cardboard presentation. We are presenting the whole vertical plane in the form of a line. We are presenting the whole horizontal plane in the form of a line, not in this 3D form. And once we have a location capital A in front of vertical plane and above horizontal plane, it is represented in this form. This is the first quadrant, above horizontal plane, in front of vertical plane, this point capital A, project it on the horizontal plane, this is the plan, project it on the vertical plane, this is the elevation or view from front or front view, and this is the plan or top view or view from top. Whatever name you use, that doesn't matter, but ultimately these two are the orthographic or perpendicular projection on 2 mutually perpendicular planes whose reference names are HP and VP. But you must supplement this with serious study. In YouTube, in NPTEL, there are so many interesting videos, but you have to invest your time, your intelligence, your merit, your passion, etc. Now, this distance from horizontal plane, this distance from vertical plane, those are indicated here. Distance from horizontal plane is the lower one. With reference to the XY line, this is the HP side. So distance of this view from other plane, and this is the distance of this view from ground line or XY line from the other plane, that is VP. So very important information.
थोड़ा सा zoom करिए ना.
ये तो पहले तो बड़ा ही था, मैंने सोचा पूरा देख लिया आपने.
Yes sir, ठीक है.
Ground line, a very thin perpendicular to this XY line. on this line, mark a point at a distance. As example, it is 30 millimeter, which is given as the height of the point capital A, which is the distance above HP. And this is the distance from the vertical plane coming below the XY line. Because when you rotate this location comes down below the XY line. Okay. So very important step. Now, once we have this knowledge completely digested, then we go to the second step, other quadrants. Now, can I move to those quadrants?
Yes, sir.
Okay.
Yes, sir.
Now here, what about the position of capital B? This is behind VP. And above HP. That is, it is second quadrant. Now, B is the location given. You drop a perpendicular on vertical plane. You get this point. This is front view or view from front or elevation, and this distance is the height or distance from horizontal plane. Now, if it is below horizontal plane, then that formal word height is not applicable. So distance from horizontal plane, whether it is above or below, so we will not bother about that, DH. And this is the distance from vertical plane, whether it is behind or in front of vertical plane, we don't bother about that. But only thing, the distances of this view from front or front view or elevation, and this is the view from top or top view or plan. Whatever name you use, these are the projection of this point capital B on the vertical plane and on the horizontal plane when its position is in second quadrant, that is behind VP and above HP. Done? Then the similar thing, you need to open this first quadrant. But that is fixed. Object is in second quadrant, but we need to open this space. So for that, this 90 degree movement about this line XY will give you the HP is overlapped on VP, and there you get the 2D presentation of these two different views. Now, this point was the plan. Now, when you rotate, it travels to this location. And the formal way of that engineering drawing is that step 1, draw the line XY, a thick horizontal line. Draw a vertical projection line. Now here you identify this distance for B. B is the plan or view from top. Now view from top, that is on the horizontal plane. So that distance will show the distance from vertical plane. So this is actually DV. and the elevation shows the height distance from horizontal plane. So somewhere here we identify that location which is at a distance dh, or that height of that point capital B. So what about the names? Names are, this is the top view, this is the front view. This front view gives the height dh and top view gives the distance from the vertical plane. So distance from the vertical plane is given distance of plane in either below or above ground line. So similar to the previous situation of first quadrant, you can understand what formality we need to maintain. Place it here, project on this vertical plane, horizontal plane, then rotate this horizontal plane clockwise to 90 degrees so that this space open from 90 degree to 180 degree, this first quadrant. It is fixed. And this is the finally the formal diagram which is called the orthographic projection solution for this particular question, that a point capital B is there which is at a distance dh above horizontal plane and dv behind vertical plane. Okay. Now similar situation we can accept for third quadrant also. So when you take up this point C in third quadrant, that is behind VP and below HP. Okay. So this is behind VP and below HP. When this angle is this 90 degree is corresponding to opening this space, so it travels back. Now when it travels upward, so naturally this plane location C, it shifts here. So finally this 3D representation to 2D representation will give you this diagram. This is XY line on a very thin projection line perpendicular to the ground line XY. We mark two locations, small c and small c dash, where small c is the distance of plane from ground line is equal to distance of the point from the vertical plane. Distance of plane E. Sorry, this is C. So distance of plane C from XY is equal to distance of the actual point capital C from here vertical plane. So distance from vertical plane, it is shown in distance of plane, and similarly dh, the distance of the elevation from ground line, will be the distance of the point capital C from the horizontal plane. So these things are very simple, but you must understand what are the formalities: first angle, first quadrant, second quadrant, third quadrant, and fourth quadrant. Now here in this third quadrant position of this point C, it gives us elevation below GL and plane above GL. But in first angle projection, the elevation, this is second quadrant, this is first angle. So elevation is above GL and plane is below GL. So this difference is there for first angle and third angle, which are normally accepted. For India, Russia, and many European countries, we follow first angle projection, and United States and some other followers, they use the third angle projection. Now for third angle projection, it is essential that you are the observer here. So you have to see this point capital C. So naturally, this plane needs to be transparent. It's not like that you are holding a torch behind this point C and forming a shadow here. It's not like that. You are connecting this point C with a line which is perpendicular to this vertical plane, and this imaginary location is called the projection of this capital C on this vertical plane, indicated by small c dash. Okay. But anyway, for first angle and third angle, things are convenient for us because those are indicated at their distinct locations, not on the same side of the ground line. Okay, so here plane is above GL, elevation below GL, but those are at two different sides. For first angle also, the point A and A dash, those are on two different sides. A dash the elevation above ground line and A the plane below ground line, on two different sides. For second quadrant, elevation plane both are on the same side above GL. Problem will be, we may not understand the trouble for a single point. But if by any chance this is not a single point, there are so many points, suppose a real object. So shadow of the object formed on the vertical plane being overlapped by the shadow of the object formed on the horizontal plane, and due to this opening up the first quadrant. So that is the overlap diagram, making the things clumsy, and no fruitful information you will get it from this. And the last one is the fourth quadrant position. D is here. This is the view from top projected on this horizontal plane, small d. This is the elevation, d prime, that is below horizontal plane and in front of vertical plane. Now horizontal plane you need to rotate through 90 degrees so that a 3D presentation comes in the form of 2D representation. So from this location, D travels through this circular arc, and this quarter circular arc meets on this vertical plane at point small d. Okay, for the real particle or the point capital D. And this is the formal presentation in plane and elevation with reference to this ground line XY. This is the perpendicular projector. This is plane below GL, elevation, both below GL. So there is a possibility for a real object, these two projections are coming one over the other and making the whole things clumsy, and no distinct solution you can get from this. Now with this basic knowledge, from your screenshot you can find, anyway, either today or tomorrow I'll send you the full problem sheet for plane number 3. I thought I send you anyway. It was my mistake. Now for problem 1, points in different quadrants. 4 points are there. P, Q, R and S are situated in different quadrants, that is dihedral angles. Draw view from front and view from above for each of them. So can you hear me, or it is one-way traffic light?
Yes, sir, we can hear you.
Okay. So now by this statement, above HP and in
So
front of
nobody can mute you.
Okay. So by this description, above HP and in front of VP, it means it is in first quadrant. By this description, above HP and behind VP, it is in second quadrant. Below HP and behind VP, this is the third quadrant. And anyway, for your convenience, I can do this thing. Front, behind, above, below. So the point P is placed in first quadrant from this description. P. Q is above HP and behind VP. R is below HP behind VP. And S is below HP and in front of VP. Done? Now in the third page, the complete solution of this is given. So nothing to worry about that. So just go through the solution steps. First quadrant, on this projector line, you have to mark this plan. Now what about the distance of this plan or view from top from this ground line XY? The distance of this view will be distance of the point from the other plane. What about the other plane? This side is VP. So distance of the point from VP. So point P is 40 millimeter above HP and 20 millimeter in front of VP. So this is the distance 20 millimeter and 40 millimeter above HP. It will come in elevation. So draw this ground line XY, then draw a thin, very thin projector line. Then on that projector line, you mark two locations at 20 millimeter below XY and 40 millimeter above XY. Put the extension lines, put the dimension line, put the dimension arrowhead according to those formality you have learnt in your plate number 1. Put the dimension figures 20 and 40, and somewhere on the drawing sheet it will be written as a common information that all dimensions in millimeter. Done? Do you have any ambiguity about this solution? Any query?
No, sir.
No,
Okay.
sir.
So for the second case, for point Q, capital Q, it is 15 millimeter, 45 millimeter above HP. So Q is 45 millimeter above HP means it is 45 and 15 millimeter behind VP. Okay, so this is Q. Now projection on vertical plane, it will be Q dash. Projection on the horizontal plane, it will be lowercase q. And in this diagram, you will find 15 millimeter behind VP. Okay. 15 millimeter behind VP means it is the plane, and 45 millimeter above HP, it is the elevation. So this is the name Q and Q dash in lowercase. For third angle projection, it is 25 millimeter behind VP. So 25 millimeter behind VP means it is coming in plane. So that 25 millimeter in plane, it moves upward, so it is R, and 50 millimeter below HP, that is in elevation, so it is R dash for third quadrant. Now for fourth quadrant, both of these views will come below this. It is somewhere here, 45 millimeter below HP and 10 millimeter in front of VP. It is here. It is 10 and it is 45. So 45 millimeter below HP, it will be the elevation, and 10 millimeter below XY, it will be the plane. So this is plane, 10 millimeter in front of VP and 45 millimeter below HP. So distance from HP comes in elevation, distance from VP comes in plane. And other names for this plane or elevation, those are like that. View from above, this is the plane. View from front, this is the elevation or front view. And this is view from above, means view from top or top view or plane. Now please take a screenshot for this page where these names are given for your convenience. Now one thing I would prefer, that the problem sheet, it is stored in your system. The class you are considering or you are attending, that is also in your system. So every time it is very difficult to compare those information or the questions along with its corresponding solution. So what I would prefer, you just take printouts from your nearby photocopying shop or cyber cafe. Okay, so just have one hard copy of these 3 pages for plate number 3, projection of points, lines and surfaces. It will be very useful for you. Okay, now nowadays we keep, many of us, particularly for this pandemic situation, we keep printer also at our houses. So if you have that facility very close to you, just you can avail that and get these 3 pages print out. It will be very helpful. And you must be ready with your paper, pencil, scale, eraser, and if possible divider and compass for measuring angles. Okay, now these right angles, so whatever we are making, this is not through that protractor, this is not through that standard 8 of your school geometrical principle, that construction methods, not in that way. Simply use 2 set squares or that diagonal scale where 90-degree arrow is there, directly you can draw these perpendicular lines. So all these lines will be drawn on this XY. These lines are perpendicular to the XY line or ground line. Now, can you venture this thing? Just see this diagram and on the white paper, whatever you have taken, you just try to make this thing. But that measurement you should take very carefully. 20 millimeter, 40 millimeter, 45, 15, they should not look like the same distance. They should be represented properly. 45 must be 3 times of this 15, or this 40 will be double of this 20, etc. in that way, or 50 will be double of this length 25. Okay, do you get my point? So please do it. The first, what you do, you just take a screenshot of this solution. You will make that you require hardly 5-6 minutes for that. So can I move from this screen?
Yes, sir.
Yes, sir. Done.
Okay. So within 5-6 minutes, you just try to do something. Okay. It will definitely you will find some interest. Draw a horizontal line which will be the ground line XY. On that, draw a vertical line. Measure two locations 20 millimeter below XY and 40 millimeter above XY, representing the plan and elevation or the view from top and view from front. Now the dimension formalities, extension line, dimension arrowhead, dimension figure, etc. But you have to do it with your own hand, otherwise it will be very difficult, particularly for this pandemic situation when you are not allowed to attend the regular classroom or drawing hall classes. Naturally, really you are missing so many important things, because this subject is different from others. Okay.
Yes, sir. सर आप म्यूटेड हैं। सर आप म्यूटेड हैं।
हाँ, तो डन।
What happened?
For whom?
Sir, done.
Okay. Just एक मिनट बेटा. Now, can anybody show your performance? Any volunteer?
Yes, sir. Wait a minute, sir. I am trying, sir.
What is your roll number?
Sir, I section roll number 4.
I section roll number 4. Okay, so I will just unshare this.
Sir, only sir, organizer and presenter can share their screen. I can't share my screen, sir.
That means you are attendee only.
Yes, sir. Can I mail you, sir?
Now, one thing, if you cannot share or you are defined as attendee, then how you can mute other people or you can drive out some other people?
No, sir. Some presenter make us attendee. Someone make us attendee, sir. Presenter can make other people attendee, sir.
You are attendee only. You are defined in that way. Presenter is only myself.
No, sir. All are not attendees. Some presenter make us attendee, sir. They might think, sir, I am removing them, sir. So they make me attendee.
Anyway, some video was coming. I was getting something that ceiling fan or something like that.
But I tried, but I couldn't show my face.
আমি আপনাকে স্যার মেল করে দেবো স্যার আপনি তাহলে স্ক্রিনটা
No, mail করতে হবে না. It is during the running class only if it is possible, because in our last class also you could share. Some of you were sharing some to show your performance there. Anyway, I'll share that my.
নয়তো সুমিত অর্পণকে বলে দে, অর্পণ তাহলে তোকে প্রেজেন্টার বানিয়ে দেবে।
Now, do you have that problem sheet ready in front of you? Or even if it is not ready, I'll just go to the next problem. For each of the points mentioned below, please go through this statement. Separately, it has been copied beside the solution. This solution is also there for 2A and 2B, 2C, D and E to be solved accordingly from your understandings. Now, 5 points are there. For each of the points mentioned below, draw views as asked. Refer figure problem 2. Point A, 45 millimeter above HP and 25 millimeter in front of VP. So from this description, definitely we understand the point is in first quadrant, above HP in front of VP. We need to draw elevation, plan and view from left. Now, elevation will be above GL. What about the distance of elevation? That is the height of the point above HP, that is 45 millimeter. And 25 millimeter in front of VP, that distance will come in plan, that's the view from top. Okay. So you draw these two things first. Now I will show the steps here. First step, you draw this XY line. Second step, you draw a thin vertical line. Perpendicular to this XY line. On that thin vertical line, mark 2 points at a distance 45 millimeter above XY and 25 millimeter below XY, which will be the plan and elevation. That is the fourth step. Mark them. Step 5 is to draw these extension lines. Draw this dimension line, put the dimension arrowhead and put this dimension figures. Step 5 done. Next step, step 6, you draw another axis for showing the side view, view from left. For first angle projection, view from left will be coming on right hand side. So after this step 6, step 7 is you draw a horizontal line through this plan point 7. Plan point, that is small a. Next step, about this center, taking this distance as radius, draw this semicircular, quarter circular arc to reach up to this point. That is step 8. Step 9 is draw a vertical line through this point. Maybe it will extend a little bit. We do not know exactly that level, the height dh. Then step 9 will be draw a horizontal line. Step 10. Step 10 will be to draw a horizontal line passing through this elevation and get this point of intersection. It will be the view from left, A double dash. Because it is satisfying the same height, distance from horizontal plane, that is 45 degree, 45 millimeter, and distance from vertical plane, that is this much. Same thing, the 25. Okay. So if you follow these steps very carefully, there should not be any problem. The complete description is given in your problem sheet, that solution, and with the help or with this guidance, you can go for the other solution, C, D, and E. Now I will repeat it once more. Step 1, draw the XY line. Step 2, draw this thin line perpendicular to this XY line. This is the projector line. Then identify these two distances at 45 millimeter above GL and 25 millimeter below GL to represent the elevation and plane. In the next step, we identify this plane and elevation A and A dash. In next step, step 5, we show these extension lines, the dimension lines, the dimension arrowheads, and these dimension figures all in step 5. Step 6, draw this axis. Step 7, through this point, draw a line parallel to GL. You reach to this point, use this point as center, taking this distance as radius, you draw this circular arc. That is step 8. We reach here. From here, we extend a line perpendicular to GL. From the elevation, we draw a horizontal line to maintain the height 45 millimeter. So this horizontal line is parallel to this ground line XY. So definitely this step 10 will give us this point of intersection between these two primary clues. That is, side view will be located at same height of elevation and side view will be located at same distance of plane from the ground line. So this is the distance 25 and this is the height 45. So this is the required thing, that is view from left or left side view. So small a dash, small a double dash with clear indication of their location with a very small circle and putting all the dimension. Is it okay?
Yes, sir.
Now, this part is very important. Now, there are so many very good books. You may not need any teacher like me. Okay. Only thing you have to provide little capital from your unlimited intelligence, memory, your patience, your intellect, your zeal, etc. Now, as this distance from the vertical plane to be indicated here, dv. So this is the method that we are making a quarter circular arc using this as center and this dv as radius. We are reaching to this location, so definitely this is also dv, and when you are drawing a perpendicular line, everywhere it will be at a distance of dv, that is 25, 25, 25, etc. Okay. Now, if we, instead of this quarter circular arc, if we draw one 45-degree line, then what would we get?
Right angle triangle.
Right angle triangle?
Yes, sir.
And this distance will be right angled isosceles triangle.
Yes, sir. Right angle isosceles.
So this is dv and this is also dv. This is one method. Another method is also there to reproduce this distance or copy this distance dv to this horizontal line, so that the side view is at a distance of dv from the side axis. Another geometrical, very simple geometrical way is there, that is, draw one very thin 45-degree line. Draw a 45-degree line from this point. This is step 1. Step 2, we draw a horizontal line through plane, and through this point of intersection we draw a vertical line. This is step 3. Now what about this distance?
Same, sir. 25.
Same, dv. So what we can do, when we are to find out that side view, it may be looking from left, it may be looking from right, whatever it may be, this, just 1 minute, it will take little time. This is the horizontal axis. This is the vertical axis. On the left hand side, this is the VP side. On the lower side, this is HP side. On the right hand top corner, it is the presentation for side view for first angle projection. Okay. So if this is the distance dv to be located here, one method is this quarter circular arc. Another method is from this point we draw a 45-degree line, or another way, that is, draw a 45-degree line from this point. Next, through the plane A, draw a horizontal line, and where it intersects through that point, draw a vertical line. So either 1 or 2 or 3, 3, 3. 3 first step, 3 second step, and this is 3 third step. Or you can do, it may be a little bit confusing, first step A, second step B, third step C. Done?
Yes, sir.
This is the location for the plan A. Now, benefit of this third alternative is that only thing you need to draw a series of horizontal lines and a series of vertical lines. What is very easily can be done through the set squares. For first one, this green line, you need to draw a circle where from this center, where there is a possibility, not possibility, it's sure that the needle of that compass will pierce that paper through and make a hole there. And naturally, if there are many such locations in plan A, B, C, D, E, F, G, etc. So for all these points, you need to suppose there are 7 plan points. So for that 7 plan points, you need to draw 7 quarter circular arcs of different radius, and that center mark, that is the punch mark or that needle hole, it will become bigger and bigger. And all these circular lines will make some clumsy thing there. Anyway, that is not much damaging. Next thing, the option 2. For option 2, you need to draw a series of 45-degree lines. If there are 7 points, you need to draw 7 45-degree lines. But horizontal, vertical, those lines are directly available from your that drafter, or it's comfortably. But for 45-degree lines, there is little possibility that you make some error there while making those angles, etc. Anyway, at least some trouble you can reduce by this third method, where we are having only one 45-degree line, that is once for all. Okay, then for 7 points in plan A, B, C, D, E, F, G, for A, horizontal line, vertical line, for B, horizontal, vertical, for C, horizontal, vertical. It's very simple. So it depends on the situation what method you should adopt for 1 or 2 points, whether you take 2 circular arcs or 2 these blue lines 45-degree, or for many number of points you can draw a single 45-degree line from that point of intersection of these 2 axes, the horizontal axis and the vertical axis, and from that a single 45-degree line, just draw series of horizontal lines, get the point of intersection with that single 45-degree line, and through those points of intersection draw vertical lines. So these formalities are very important, and this is not like mathematics or physics or chemistry like thing, not like mechanics also. Okay, you need real practice. Calculator will not help you here. Only thing, your confidence of working with pencil, eraser, set square, scale, and the drawing instruments. Okay, it's very important. And through YouTube or any other such source, please go through about this video description. Those are really fantastic. Okay, do you have any question?
Sir, one thing in that image that you that was sent, it was said 3 out of 4 questions. So 3 questions will come from trusses and centroid, and 4th one will come from previous CA1 syllabus.
The syllabus is highlighted one, trusses and centroid.
No, sir, I am asking that it was written 3 out of 4. That was that's why I was asking.
Syllabus is truss and centroid.
Okay, sir. Then 4 questions will come from there only, right?
Yes. Some portion of truss we discussed in our CA1 portion. Okay, but truss means full, method of joint, method of section, complete.
Okay, sir.
Okay, truss means full truss. Now regarding problem 2b, it will be a little bit different. Anyway, I will erase this additional information so that things are not clumsy and confusing us. First of all, what about the problem statement for part B? 20 millimeter above HP and 40 millimeter in front of VP. Above HP in front of VP means it is in first quadrant. That is fine. Then draw elevation plan and view from right. That is the important thing. View from right. It is not this left. Okay. So please remember that when you need to show that thing view from right, you have to put it on the other side. Formalities are same. At same height from the horizontal plane, at same distance from the vertical plane as it is there in plane. So this distance will be $40 millimeter and this distance will be 20 millimeter. That's fine, but we are not calculating. Simply we are using the geometrical tools to locate it here. It's not like that along this line you measure a length 40 millimeter, definitely not. And we are using this method of 45-degree line. Only thing, this thing is shifted towards left. When you are looking from right, you project on the PP placed on the left and open that space. Now I think if I can draw some separate diagram, it will be very easy for us. VP, HP and PP. Suppose this is the point B. Project on the horizontal plane, it will be view from top. Project on the vertical plane, it will be view from front. Project on the PP placed on the left. So we are seeing from right. Okay. And you need to open this horizontal plane or move this, rotate this horizontal plane through 90 degree and rotate this PP through 90 degree so that it overlaps with this vertical plane. So ultimately you will get this combination as if these are three cardboard pieces and here you will show that view from right. Okay, so if we have that elevation plan combination here, this is elevation in first angle, elevation above GL, plan below GL, then definitely you need to maintain that height. Which height? The elevation distance. and you need to maintain that dv through plane, then whether this 45-degree line or this quarter circular arc or this 45-degree line, then horizontal vertical, ultimately you will get this point, that dv distance. Okay, now this will be view from right. Okay, so please understand these things carefully. And definitely you can solve the remaining parts C, D, and E. C is on the VP and 30 millimeter above HP. Draw elevation plan and view from left. D on the HP and 20 millimeter in front of VP. Draw elevation plan and view from right. E on the ground line. Draw elevation plan and view from right. So it will be easy for us if we take up one that 3D pictorial like thing. Now the point is located on the vertical plane and 30 millimeter above HP. So this is the point on the vertical plane and its view from top is here. So this is point C, C on the vertical plane. So C and small c, they are same. Sorry, the elevation C prime, and this location is small c, the plane. So ultimately what we get, this is the ground line. We draw that projection line. Now this foot of this perpendicular, this is plane of the point C, and this is elevation of the point C. So when a point is there on the vertical plane, its shadow will be on the ground line or XY line. Similarly, if there is a point on the horizontal plane, so the point itself is the plane, and its projection on the vertical plane, which is the elevation d dash, it will be on the ground line itself. So when you draw that ground line, then draw the projection line below the ground line. There will be the plane at the distance specified, and on the ground line itself the elevation will be there because the point is on the horizontal plane. So point on the horizontal plane means the distance of the point from the horizontal plane is 0. Now distance of the point from the horizontal plane is available in that height of the elevation or distance of the elevation from ground line. So naturally that distance will be 0. So for elevation d dash, if there is no distance from ground line, so naturally it is located on the ground line. So this visualization may or may not be given in every detail in any book, but these things are very simple. You can yourself make such kind of 3D presentation like thing and try to understand where it is located, where its plan and elevation are going in that way. And if there is a point E on the ground line, then this is something like a special location. So here is a point E. So naturally the same point when you see from top, the same point is coming as the view from top. When you are looking from front, the same location will be coming as view from front or elevation. And ultimately, if we draw the XY line or ground line, on the ground line itself, the point will show the plane or view from top or top view or view from above, as well as the view from front or front view or elevation. So this is the clue that I can give, and you must try now with the real sizes, dimension, etc. to show that C prime, D prime, and location of E in plan and elevation. But you show only this formal process of representation, not that way of this 3D model like thing for better understanding, not in that way. This is for understanding part, but this is for real engineering practice. Have any question here?
What is the view from left, sir? View from left, from view from right on for the point located at ground line.
Now for part C on the VP, 30 millimeter above HP, etc. Draw elevation pattern view from left. Okay, C for left. That is conventional. This axis will be on the right. This is at this level. Here, what about the distance from vertical plane for C? It is 0. So definitely a 0 distance from this line will give us a location on this line. So from this line at this height, this will be C double dash. For fourth one, D, view from right. So this axis will be on the left. Through D, draw a horizontal line. Now through this point, draw a 45-degree line.
Sir, in question C, where is the point A double dash? I mean C double dash.
C double dash is here on this axis itself, because 0 from this distance from this axis is dB, that is 0, because C is on the vertical plane, so its distance of plane is also at 0 distance from the ground line.
Okay, sir.
For D, what about the height of this end view or side view? Because the point is located on the horizontal plane, there is no height, so height is 0. So it is here. This is side view. And view from left for the fifth one, draw this side view axis. Distance from vertical plane, distance from horizontal plane, both are 0 because it is on the ground line. So once it is on the ground line, so definitely the distance from this vertical axis, it is 0. That means it is along this line. And height is 0. So distance from this line is 0. So this is along this line. So this is the location which satisfies both of these information. So this is view from left. Okay.
Also, sir, this is view from right, sir. No?
Or last one, E, view from left.
Yes, sir. No, yes, sir. If we take a view from right, in for this case, it is also, sir, E dash.
Here only.
Yes, sir.
At
Yes,
the
sir.
intersection of these two
Sir,
axes.
the common point between three planes.
Of course, it is coming here. You are seeing from this direction and projecting on this profile plane. So it comes here.
Okay, sir. Get it, sir.
Things are not difficult. It is very interesting, very simple, very easy. But your ability of visualization is the primary investment. Please do it. And as you know, I repeat that old cassette that please go through any book and many book. Go through the solved example first. Understand it completely and properly. That's all. Then you try end of the chapter problem. Wherever you get stuck up, you discuss in your batch section H and I. Finally, this service provider is there with my knowledge limit. Okay. So please do these things with your own hand. Then you will get confidence and you will find interest. Otherwise, sir, solution दे दीजिए बाद में देख लेंगे. It will not help you. And I repeat, this subject is language of engineers. This drawing, a very important subject. Now, after 1 and 2, let us think about problem 3. Oh, here it was showing that attendees, 129 attendees, and presenter is only 1. I don't know what's happening. Anyway. Now, can anybody read out the statement?
Attendees.
Can anybody read out the statement of problem 3? As I am sharing this page, I don't want to move out from this.
Yes, it says draw elevation, plane and view from left of the line AB when A is 10 millimeter above horizontal plane and 20 millimeter in the front of vertical plane, while B is 40 millimeter above horizontal plane and 45 millimeter in front of vertical plane. The distance between the projectors and of A and B measured along GL being 40 millimeters. That's the part 1, and part 2 is draw elevation, plane and view from the right of the line CD, and C is on horizontal plane and 30 millimeter in front of vertical plane, while D is 35 millimeter above horizontal plane and on vertical plane. The distance between the projectors C and D is 40 millimeters. And the part C is draw elevation, plane and view from left of the line EF when E is 45 millimeter above horizontal plane and 10 millimeter in front of vertical plane, while F is 15 millimeter above horizontal plane and 40 millimeter in front of vertical plane. The projector of E coincides with that of F.
Oh, 3 parts are there, but it is regarding one thing. It is personal to you. That is, whenever you take these 2 words, this is plan, that this is my plan. I am planning to do like that. Plan view from top. And this is plane, a surface. Okay. So don't pronounce this plan in the form of this plane. Okay. And one more common thing, that some method, sometimes it is called principle. suppose some method virtual work in your syllabus is there, a principle of virtual work. Sometimes we write it as but this is not principle. This is principal, the director, the head of an institute or school or college. This is principal. It should be principle. So this is my experience when I go through your scripts. So this principle and principal, and regarding pronunciation, this plan and plain. Okay, please don't mind. ये बुड्ढे लोग कुछ ज्यादा बकवास करते हैं, बकबक करते हैं. So please. Now next thing, information given for this problem 3, part 1. It is a straight line AB is there. Okay. So AB is the straight line where point A is given in the form of this information 20 millimeter in front of vertical plane and 10 millimeter above horizontal plane. Am I right? So at a location 20 millimeter below GL and 10 millimeter above GL, locate this plane and elevation of the point A. Next, for point B, 45 millimeter distance from vertical plane. That is, this is the vertical plane side, the upper side. So distance from vertical plane in that view, it will come below here on the other side. So this is corresponding to location of this B. And this is the elevation. But one thing is sure, it may be anywhere. It may be here also. And one more important clue is that plane and elevation of a point, they must be connected by a single projector. This one. So for B and B dash connected by a vertical line or the line perpendicular to XY. A and A dash planar elevation connected by a single projector line perpendicular to XY. So this thing you have to satisfy. And from this part given clue, if B and B dash are the plane elevation, of course it satisfies that 45 and 40 millimeter distances. It could be here also. But thing is that point B cannot be at any location arbitrarily. The logic given is that the projector through A and projector through B, they are at a distance of 40 millimeter from each other. Okay. So first step, I'll come back to the original diagram. Step 1, you draw this XY line. Step 2 is at a distance of 20 millimeter, 10 millimeter, identify this plane elevation of point A. Step 3 is draw a horizontal line at a distance 40 millimeter above GL and 45 millimeter below GL. Draw these lines and at a distance 40 millimeter, this is step 4. Draw this line and get this point of intersection with this horizontal and vertical lines. That is the step 5 to get the plane and elevation. Okay, I'll repeat. Step 1, draw this horizontal axis, XY ground line. Step 2, locate plane elevation from the given information for capital A. Distance of B and B dash, that is plane elevation of capital B, will be at these heights that is mentioned at this distance from the GL. But this 40 millimeter criteria you have to satisfy. So in the third step, we draw these horizontal lines that is giving the distances at which B and B dash will be there. Then at a distance 40 millimeter, draw this line, vertical projector line, line 4. And this point of intersection will give us the location of plan and elevation B and B prime. Okay. Is it okay?
Yes, sir.
So first part is over. Second part, to draw the view from left. So view from left means the axis will be on the right hand side of this plan elevation. So step 1 is this. Then step 2 is from this point draw a 45-degree line. Okay. Step 3 is draw these horizontal lines from plan points A and B. Step 4 is from these points of intersection with this 45-degree line and this horizontal line through A and B, draw these vertical projectors. Step 6 is draw the height lines from the elevations A dash and B dash. Step 7 is identify these points of intersection with this horizontal vertical corresponding to plan A. Here will be elevation level A dash and this is the A double prime. Similarly, here also the B, can you see this cursor movement, this horizontal movement of this cursor?
No, sir, it's a bit laggy.
So from B, draw a horizontal line, reach the 45-degree line. From that point of intersection, draw a vertical line indicated by line 5. And this is the second part of step 7. And this is step 8, join A double dash and B double dash. This is the view from left. Oh, sorry. View from left for the line capital A, capital B. Okay. This is elevation. This is plan. And by its name itself, it is automatically meaning the A without any dash or prime, it is plan. A with a single prime, it is elevation. And A and B lowercase with double dashes, these are indicating the view from side. And these notations are rigid. You cannot use A double dash, B double dash for plan, AB for elevation, and A dash B dash for side view. It's not like that. Okay. Now next thing regarding second part. Second part, there is a line CD. Anyway, before going to second part, I will erase this informations. Otherwise, it will make the things clumsy. Now, what about point C? Can anybody tell me what is the statement, problem statement? Location of point capital C?
On HP and 30 millimeter from VP.
So on HP and 30 millimeters from VP. So its elevation will be here, and plane and the point itself directly on the HP. And what about point D? D is on VP.
35 mm after above HP and on VP.
This is on VP and 35 millimeter above HP. So this is elevation and this is on the ground line itself. This is the plane. So that's why when we connect these 2 points in elevation, we get the elevation of the line. And when we connect the points, terminal points C and D in plane, we get the plane of the line. Okay. So this is very important. A straight line is a combination of infinite number of points. But when we draw a straight line, we are showing infinite number of points by 2 simple terminal points A and B or C and D. That's all, and connect them by the shortest route. So similarly, all infinite points on the straight line AB or CD, they have infinite number of plane points and infinite number of elevation points in between the terminal points A and B or C and D, etc. So it's our job to locate the terminal points in plane, suppose plane of C and plane of D, and join them. It will automatically give all the infinite number of points of the straight line coming on that line joining the plane of the terminal points small c and small d. So this is the plane of CD and this is
class
elevation of CD. Okay. So that thing is here. C dash is coming here on the ground line. C is on the HP, that is at a distance 30 millimeter. Similarly, plane of D on the ground line and D dash at the given height 35 millimeter. You join them and satisfy this one. So step 1 is naturally we are working on this same ground line. Step 1. Then step 2 is identify C and C dash. Step 3 is restrict the height. Step 3 is here, not this one, because we have only one distance. This distance is 0 because it is already there. Line GL is for height 3 for the point D. Then this is step 4, 40 millimeter. Draw this thing, this vertical line. Step 5, get this point of intersection and you join. And to get the view from right, C located on the HP. So DV you will find this height is here 0. The point D is on the vertical plane, so it is here. From vertical plane distance is 0. So this is the distance from vertical plane, that is 0, and you join it, view from right. But third part is little special, and suppose you take a set square and make it parallel to the profile plane. That similar kind of thing will be available here. Okay, so please extend this thing for this problem, whatever it is there, but it needs your attention. It's very difficult to any other person. It is difficult for any other person to make you understand about this subject until and unless you build up that ability of visualization and own thought process. Okay? And these problems, once you start solving gradually from a point, then extend the idea of point for 2 points, join them by the shortest route you will get for a straight line, then a series of straight lines forming a boundary, a plane surface minimum is a triangle, then a square or rectangle or a quadrilateral or parallelogram, then pentagon, regular, irregular, hexagon, regular, irregular, etc. We learn it gradually, but before that, please go through any book, any YouTube video, any NPTEL lecture, etc. to supplement this primary discussion. Okay, but you please don't move, don't leave. I need to take your attendance. Okay. So it is showing, it is prompting downloaded, but I need to check it at my download folders. Yes, it's there. Now, please give some time. Okay. Now, all these details are very important. Extension line, dimension arrowhead, dimension figures, etc. It will take a lot of time. So just simply working with this line AB, line A dash B dash and line A double dash B double dash, it is not that complete solution. You will get only part mark. Everything is important for this presentation of that particular solution. Okay. So do you permit me to leave?
Yes, sir.
Please send us a plate 3, sir. Please send
Yes,
plate 3.
sir. You may leave.
Send a mail, sir.
I'll send it. I'll send it. Nothing to worry.
Thank you, sir.
Okay, sir. Thank you, sir.
Thank you, sir.
रिकॉर्डिंग ऑफ करके भाग जाओ.
गुड नाइट. रिकॉर्डिंग ऑफ
सर
করে
है
যাচ্ছে না
सर
তো.
नहीं गए.
यही कर सकते हैं
জয়দীপ
अ,
already করতে পারে।
योगा में